Hey everybody, this is Coach Lowe coming to you with a little 4.4 for you. This is going to be shape, center, and spread with numerical graphs. And there will be histograms and there will be box plots galore. And there's going to be a lot of details here, so I will probably have to break this up into a couple of videos. Just saying. So hang on, let me get the ink rolling here. Let's go with this. I'm feeling a little bit natural here. Let's go with the green. All right, y'all ready? All right, so here we go, shape, center, and spread with numerical graphs. All right, so when describing data, we want to talk about SOX, which is going to be the shape, and it's going to be outliers, and it's going to be the center, and it's going to be the spread. That is whether it's a histogram or box plot, this is what we want to talk about. So if they refer to SOX, we're going for the shape details, the outliers, center, and spread. Some more in detail for those. So recall, these are the measures of center. We like the mean, which is the average value, and of course the median, the middle value, when the values are in order from smallest to largest. If the mean and the median are not the same, that means your data is skewed one direction or the other. And just to throw this out here, spoiler alert, the mean tends to be a little fickle, and if your data is skewed, the mean will follow those outliers, whatever direction that is. Median definitely has a little bit more backbone, so when your information is skewed, don't be surprised if we come here for our true measure of center, the median, okay? All right, moving on. Also recall, these are the measures of spread, so how much your data is spread out. We'll use the range, which is going to be the distance from the highest to the lowest, maximum to the minimum. And then for all you box plot people, the IQR, which is going to come from the actual box in your box plot. It represents the middle 50% of your data, and that is coming from your Q3 minus your Q1. That's where you get the IQR from. So the larger the range or the IQR, either way, the more spread out, of course, your data will be. All right, so here we go. Good example, 2001 NFL season. Tom Brady and the New England Patriots took over the quarterback position and led his team to a Super Bowl championship. Here are his passing ratings for each of the 15 regular season games. So calculate the mean and median of Brady's passer ratings. Based on your calculations, is the data skewed? And then the next question would be calculate the range, interquartile range for Brady's passer ratings. And what does this tell you about basically the spread of the data? So what I did, instead of just going ahead and throwing this into the calculator, I decided I am going to show y'all a little bit of technology right off the bat. So hang on, let's scroll down here. So if you took these, let's see how many we got. 1, 2, 3, 4, 5, 6. We got 12 data points here. So here we go. So I got my 12. You can come to your graphing calculator. You're going to hit the stat button. And you're going to get this screen right here. You're going to hit enter on edit. That's what we want. That's going to take you to your list. And what you'll do is you'll plug in each one of those items right here, which I hope I did correctly. And so there they are in list one, and always take note of which list you're in because it does kind of matter. Then what you can do is go back, hit the stat button again, and this time you're going to arrow over to calculate and hit enter. You're going to see this list. So again, make sure this is correct. Make sure if your information is in list one, make sure this is reading list one. Then you're just going to hit enter, enter, all the way to the bottom, and then it's going to bring you up this, and this is the jackpot. This is stuff that you don't have to find if you're using your technology. At the top, X bar, this is going to be your mean. So are we ready here? Yeah. So right here, this is your average, this is your mean. And again, we'll call this X bar. We will not use these. Well, every now and then we might start talking about these two. This is your two standard deviations, but not yet. So up here, X bar is your mean. We're going to come down here. N, always worth double checking. This is how many items you put in. So we should have 12 items that are data. So make sure N is 12. And then here we go. Min is going to be 57.1. Here's your Q1. Here's your median, Q3, and your max. So just with the last, 5 items here, you can go ahead and go straight to a box plot. So it does come in handy. Uh, and also, just to throw this in here, if you want to graph a box plot, here's what you can do. If your information is already in your list, you can come up here to hit second and then hit the y is equal to because you want the stat plot right here. It's going to bring up this screen, and basically you want to hit enter because you want to turn each one of these on however many box plots you're going to have. So for ours, we just have one set of information, so just hit enter on one. It'll bring up the screen, so make sure you click the on. And then for the type, if you notice, you got several different ways you can graph these, and there are actually 2 different ones here for box plots. And the difference is this one right here, which is blacked out, it should be the box plot, but you're going to see like a dot to the sides, which means this one will actually tell you if you have an outlier. Okay, so that's definitely a bonus. So we like to use that one. And then again, make sure this is reading from the list, the correct list, and come down here and just hit enter, what have you, and then hit graph. Go over there to the other side and hit the graph on the calculator, and it should pop up this. Now, fair warning here, depending on your information, you may have to adjust your window to accommodate your X values. Normally for the Y's, I do minimum like, -1 up to just 10 maybe, and that's probably too much. And then for the X's, again, try to account for the minimum through the max. So this is sort of how I set mine up. But if you do notice, I get the box plot right here. So I'm going to have, and just reading this off, this should be the min down here on the end. And I wish it would label it, just give you the numbers. That would be awesome. And I think, well, I don't remember what I set the scale to, so I'm not even going to do that. So your minimum is going to be down here. This should be your Q1. That's your first quartile. This is going to be your original median, aka your second quartile. And then again, the top of the box here is going to be your third quartile. And then it's kind of hard to say right in here, but that little guy sticking on in is going to be your max. And if you have a straggler out to the side, guess what? This is going to be an outlier. So whatever number that is, and if I take a wild guess, that would be your 148.3 passer rating. In this case, that is definitely outside our norm. So that is an outlier, and it would totally mess up our data. Okay, so yeah, I better wait on that one. All right, so definitely an outlier. That's what it looks like on the graph. Let's get back to the game plan here. Okay, so we use these measures to help us describe the shape of our data. And when we're talking about shape of our data, we're going to talk about 2 things, primarily symmetry and then uniformity. Okay, so if your data is skewed right, you need to understand this. If it's skewed right, that probably means you're going to have an outlier to the right. Outlier over here to the right, okay? Which is going to skew your information to the right. With the histogram, it looks like this. See how you got the tail sort of going this way? Definitely does not look symmetric. So this would definitely be skewed right, which means you probably have an outlier of some sort to the right. Using the dot plot, that's going to look like this. It still looks like you sort of have a tail to the right. And then, of course, with your box plot, you would hope to see that outlier specifically out here to the right. So here we go. That's skewed right. Okay. Some people will get this mixed up because they'll see the larger values, of course, to the left, and they'll say, hey, that's skewed left, but this is not correct. You always want to follow the tail. Okay, so if it has a tail to the right, you are skewed to the right. And that is, again, because you probably have an outlier to the right. Skew left is going to be the same thing, but going the other direction. So here's the bulk of your information, but it looks like it does tail to the left, so that is skewed left. Dot plot, definitely looks like it tails to the left, skewed left. And if you're in a box plot, you would definitely hope to see an outlier out here specifically. Outlier to the left. So outlier to the left means you will have your data skewed to the left. All right, moving on. Okay, so there was symmetry, and now there's going to be uniformity. So the heights of all the bars are exactly the same. If that's true, then you would say your data is very uniform. Of course, that normally doesn't happen. It can be close, and if it's close, again, we'll use this term roughly uniform. And you know what? I probably should have mentioned that before. Was it back here? Yeah, if you're talking about data being symmetric, again, it's rare that it's going to be in a perfect symmetry here. Okay, the same thing on both sides. You're going to see a lot of things that are going to be very close. So you just can't say it's symmetric. What you're going to say is it is roughly symmetric, which means it's almost. Okay, so when it comes to symmetry, you can be roughly symmetric, skewed to the right, skewed to the left, and then of course we have a uniformity, and doesn't happen often, but if all your bars are the same or close to it, we're going to say they're roughly uniform. Okay, going back to shape again. If you have one distinct peak, you're going to say you are unimodal. Okay, unit being one. So even though this is skewed, it looks like you got one peak, so that would be unimodal. Good point down here. Can you determine if a distribution is unimodal from a box plot? This would definitely be a little bit more difficult, okay? Because it is definitely going to depend on how your data is arranged in here. But it would be harder to use a box plot and say, hey, there's just one peak in here versus having maybe two or something. So with the box plots, it's definitely a little bit tougher. Easier to see one peak or two peaks when you're in a histogram or a dot plot. Okay, bimodal is just like what it sounds. You're going to have two distinct peaks. Okay, so you got this offshoot over here, you got that on here, so it looks like two peaks. Okay, same thing with the dot plot. And going back to the box plot, it definitely would be a little bit more difficult to see peaks if you're just going with some kind of situation like this. Okay, we don't want to be caught in a situation where we're trying to guess. So if it comes down to unimodal or bimodal, you probably need to be looking at a histogram or a dot plot. All right, here we go. Let's practice. We got a histogram here, household incomes, distributions here, 2011. It's kind of hard to see these numbers. Looks like you're going in millions, so this is crazy. But you got your categories down here, less than. That is so hard to read. So I tell you what, I'm not going to worry about the details. I'm just going to try to answer the questions. So if you're going for the shape, you would not say that it is roughly symmetric by any means. You would say, since it is going down to the right here, you would say it's tailing to the right. So you would say this is skewed right. Okay. Now, if it's skewed to the right, we got to think about what it's going to do to the center. And when we talk about the center again, this is normally where we talk about the mean and the median. So remember what I said earlier about the mean? The mean is definitely a little bit more fickle. If your information is skewed right, that means your mean is going to be moving to the right, where your median is still probably going to be back here representing the center. Okay? So again, your median is a little bit more resistant to change. Your mean is going to go wherever those outliers take it. And if your information looks like it's skewed to the right, that means your mean is going to be moving to the right. And another way of thinking about that would be saying that your median should be less than your mean in this case. And tell you what, I'll write that over here. Your median should be less than, it should be to the left of your mean because your mean moved to the right. Okay. And then we have the spread, which is going to be, and what was I saying here?